Okay, so now we're going to calculate a binomial probability. Keep in mind the last video about permutations with repetition. That's going to come back up here when we get a formula for this. So I'm going to pose the question to start this off. What's the probability in guessing on a true-false quiz that you get exactly 4 questions correct? So I've just lined up an example here. Here's a 10-question quiz, and here are your 4 questions that are correct. And so the chance you got this correct would be a half, and on down the line, the chance that you got this question correct would be halves, yeah. And then the chance that you got false, well, that would also be a half. I'm going to set it off in parentheses from the other guys. So all 6 of these guys are also going to be, they're a different 1/2, but they're still a half. Okay, so if we multiplied these together, then we would get the probability that you got 4 correct with a little hitch, is that this is actually the probability that you got the first 4 correct. And so we don't necessarily care which 4 you get correct. So we want to now ask the question, how many different ways can we order these true falses into a series of 10 letters? So hey, I'm going to put this on pause real quick and remind you that in the last video we worked a problem where we asked how about the number of arrangements of letters in the word boo-boo, and we decided it was 6 factorial over 4 factorial times 2 factorial. Okay, and so if you'll notice, what we have here in the true-false question really isn't that much different than the boo-boo question. If you imagine the B's were true and the O's were false, then we have the same kind of question going on here. Here is a word, obviously we can't really pronounce it, and we want to know how many different arrangements of these letters are there. And so it should follow pretty intuitively, if you've watched the last video, that we're going to take 10 factorial ways, that's n factorial, and we're going to divide it by the number of ways that we can arrange t, that's 4 factorial, and then the number of ways you can arrange f, that's 6 factorial. So this is the probability, the result of that calculation is the probability that we get exactly 4 of the questions correct. Okay, and with a little inspection, this is a little leap here, but not much of one. You may recognize this form of this expression. This is actually the form for combinations. So check this out. Our formula for combinations is n factorial divided by n minus r factorial times r factorial. This is the formula for n things combined r at a time. We wrote this down last week. The button in your calculator performs this calculation when you ask it. So if you'll glance back up here, if we run this as a combination now, which is a little confusing because we really do want the orders, but it turns out that in a binomial probability, when you are ordering only 2 things, the calculation comes out to look like a combination. So if we fill out the formula for combination, we would get 10 factorial on top, and on the bottom we would have 10 minus, if we want to know the number of questions we get correct, that would be 10 minus 4 factorial, and then we would multiply it by 4 factorial. And you'll see, without much thinking, that what we have here, calculating the combinations, is exactly the same as the permutations with repetition. Now that's only going to be true when you have only 2 things in the group, so it doesn't work anymore on Mississippi, because Mississippi has the repeated, it has more than 2 repeated letters. But in a binomial probability, you'll always have only the 2 choices. So here's what we get. We get that the number of ways to get 4 questions correct is a combination, 10 things taken 4 at a time, and then we're going to multiply it by the probability that we get this right, that's 1/2 4 times, times the probability we get it wrong, 1/2, I'm writing my fraction a little different there, 6 times. So the probability is the product, like it was here, except now we're taking into account that we're reordering the halves. Okay, so finally, and this is the general case, if you want the binomial probability of a certain number of trials with a success and failure probability, then we say that we take the combination of n things r at a time and we multiply it by the probability that you got success times the number of successes, and we're going to multiply it by the probability of failure, which is 1 minus p, and we're going to raise that to the number of failures, which would be n minus r. Sometimes we simplify this just a little bit by writing the combinations of n things r at a time, p to the r times q to the n minus r, where q is the probability of failure. Either one of these formulas works fine. Hey, in the next video, we'll do a few calculations to demonstrate how this formula works.